So what exactly is time? When you think of time, how do you define it? And what if everything you think about time is not completely true all of the time? In today's video, we are going to deep dive into time and see if we can figure out what it is and why it is weirder than we think. If we look at our earliest concept of time, it would have been a day on the smaller scale, and perhaps maybe a year on the larger. Though, the day was not an easy measurement for our oldest ancestors, as, well, the length of day would change, at least the sunlight part. And that made it harder to subdivide it into any form of, meaningful measurement. If you were going to meet your friend by the tar pit when the sun was highest in the sky, that would be at a different time today compared to in, say, a month from now. Or heck, what do you do if it's cloudy? The invention of the pendulum in 1956 by Christian Huygens was going to change how we measure time. A pendulum created a standard swing back and forth that, once standardized to the angle of the swing, could create a very accurate measurement that became known as a second. The full period of the swing from one side to the other and back takes 2 seconds in a seconds pendulum. Thus, from one side to the other side is 1 second. Of course, with seconds being so small, we have units that are still based on seconds, like minutes and hours, which have a predefined number of seconds. A single second is also defined as 1/86,400th of a day. Of course, the Earth's rotation does change a little due to things that happen on the planet. And it is also slowing very, very, very slowly. Because of this, we will add a leap second every so often to sync our time up with the Earth's rotation. This change to the Earth's rotation speed is very irregular. Thus, there is no defined pattern to when a leap second will be added. Modern timekeeping has moved well beyond the pendulum, and now our time is kept with an atomic clock. Radiation emitted by a cesium atom at absolute zero is extremely accurate, and the frequency of that emitted radiation from the cesium atoms can be corresponded with a hertz, which is 1 second raised to the -1. So yes, that is all pretty cool, but is it really weird? The weirdness began to peek through with a little theory called relativity. Don't worry, we're going to try and keep the math out of this discussion, but what the math did show is that time is not so standard as we thought it to be, and it was in fact, relative. What we mean is that depending on your frame of reference, time can be passing at different speeds. 1 second on Earth is not equal to 1 second on a spaceship moving closer to the speed of light. So 1 second on a spaceship moving 90% of the speed of light would be 2.29 seconds on Earth. So if those astronauts headed out to space on a 5-year mission, when they return, 11.47 years will have passed on Earth. If they were moving a little bit faster, let's say 95% of the speed of light, then their 5-year mission would be 16 years back here on Earth. And if they were going 99% of the speed of light, their 5-year mission would now be 35.4 years back here on Earth. And we're going to do just one more. If they managed to get themselves up to 99.9999% of the speed of light, that 5-year mission, back here on Earth, it would be 3,535 and a half years. Holy banana bread. Make no mistake, for the astronauts, only 5 years have passed. We cannot move at the speed of light without serious ramifications. That makes it impossible because at the speed of light, the mass of an object would need to be, infinite. But the closer we move to the speed of light, the slower time passes for us in comparison to anything moving slower. Okay, so we kind of mentioned space. So when we are in space, time is not so much just time, but rather it becomes part of the structure of the universe in the form of space-time. Space-time is basically a 4-dimensional mathematical model that makes it easier to see how time relates to speed and gravity within the universe. Speaking of gravity, it also also can make time a little bit wonky or weird. If you think of space-time as a sheet, the heavier the object you place on that sheet, the more it sinks into the sheet and affects the fabric of the sheet, or in our case, space-time. This distortion in space-time caused by very heavy masses causes a curving of space-time, which slows time around the very heavy mass. It is like being on that spaceship. The closer you get to a massive mass, like let's say a black hole, the slower you appear to be going to an outside observer. As you approach the event horizon of a black hole, you know, that line where light cannot escape, you would not actually notice anything out of the ordinary, at least in regards to time. However, that outside observer would notice that you are slowing down as you move closer and closer to the event horizon. In fact, they would never see you cross into the black hole, as from their perspective, you would freeze in time at the event horizon. As they watch you frozen in time, from your perspective, things are not so great as you experience spaghettification on your way to joining the singularity. In many ways, moving fast or moving very close to a black hole is like traveling in time to the future. But what about the past? When you look at anything, you are never seeing it as it is in the present. In fact, the further away anything is from you, the further you are looking back into time. When you look at a person sitting next to you, the light you see takes 300 meters per second to reach you. Thus, it does reach you very fast. In fact, the person next to you is a teeny, weeny little bit of a fraction of a second in the past. For all intents and purpose, we would still consider them to be in the present. Now, if you look at the sun, you can never see it in the present, as the light from the sun takes 8 minutes to reach us. So you are looking back in time 8 minutes. If the sun blew up 5 minutes ago, you would have no idea and would be out enjoying the sunshine, unaware that things were about to get bad in 3 minutes. When we look at even further away stars, we are really peering back in time. The closest star to our solar system, other than the sun, is Alpha Centauri, and they're 4.367 light years away. Thus, when we look at it, we are looking 4.367 years into the past. Betelgeuse in the constellation Orion is 642.5 light years away. Thus, it's 642.5 years in the past. We do expect Betelgeuse to go supernova soon, and when it does, we will have another bright star up in the sky for 2 to 3 months. Well, it won't be anywhere near as bright as the sun, but you'll still be able to see it. Now, Betelgeuse may have already gone supernova. If it went supernova 600 years ago, we'll start to see it in about 42.5 years from now. Now, there are some stars that are really far away. Recently, the Hubble discovered one that was 12.9 billion light years away, meaning that when we're looking at that star, we're looking 12.9 billion years into the past. Now, the James Webb Space Telescope is expected to break that record and take us even further back in time, closer to the Big Bang. But what about real-time travel? Einstein's special relativity does show us that if something were able to move faster than light, it would be moving backwards in time. However, since it is impossible to go faster than light, this is not something likely to happen. Effective, faster than light travel, like using warp bubbles, is still not moving faster than light. Moving yourself through space by expanding and contracting, the fabric of space can move you great distances, but you are not actually moving very fast at all, which is really good, as those fast speeds come with, time dilation. A spacefaring race will not have a fleet of near light speed ships, but will have much slower warp bubble or a similar technology ships to avoid all the weirdness of time when things get too fast. If you love science content, be sure to subscribe to this channel, and if you like this particular episode, be sure to time dilate that like button. Be back here next week when we will once again get our science on for another video.